Okay, so today we're going to move on to geometric sequences. We are going to go back and recap a little bit more of arithmetic sequences when we get to the sum of all terms. But for now, we're going to move on and we're going to look at the differences between the arithmetic sequences and the geometric sequences. And I'm just going to blow this very small spider off of my laptop. There we go. Okay. So just have a look at the green box and the blue box. There's 4 sequences in each, but there's a slight difference between those sequences. I just want you to have a look and see if you can work out what it is. So pause the video now and see if you can figure out the differences between the green box sequences and the blue box sequences. Okay, so the green box sequences you should recognise from last lesson. They are our arithmetic sequences. Each time you add the same number and it makes the sequence progress. So in this case we add 2 every time. 2, 4, 6, 8, 10, 12. In this case we add a half every time. 3, 3.5, 4, 4.5, 5, 5.5. In this case we add -3 each time. So we go 1, -2, -5, -8, so on. And in this case we add -0.1. So 5, -5, -5.1, -5.2, -5.3. But each time we're adding the same amount for the sequence to progress. Now in the blue box it's not the same. The difference between 2 and 4 is 2. But the difference between 4 and 8 is 4. Between 8 and 16 is 8. So we're not adding the same amount each time. This time we're multiplying by the same amount. So each time I multiply by 2. 2, 4, 8, 16, 32, 64. What am I multiplying by in this one then? Well, looking at it, it starts at 1, goes up to 3, then goes to 9. So I must be multiplying by 3. Multiply by 3 and I go 3, 9, 27, 81. What about this one then? Well, in this one, actually, I must be, so I've gone from -5 to -10 to -20 to -40 to -80. So each time I must be multiplying by 2. And in this one here, each time I must be multiplying by 10. Now, just to come back to this one quickly, if you imagine that I wasn't multiplying by 2, but instead I was multiplying by -2. So I start at -5. If I multiply that by -2, this would actually become 10. This would stay at -20. This would become 40. Because multiplying a minus by a minus gives a positive. So you can actually tell sequences where you're multiplying by a negative number because they'll fluctuate between negative and positive. So keep an eye out for that. Okay, here we go then. So in this case I have actually changed this one here so that I'm now multiplying by -2. So in an arithmetic sequence we looked last lesson at the fact that we have a common difference, D. The number that we add each time in order to make the sequence progress. Well, in this case, for the geometric sequences, we have our common ratio. And that's the number that we multiply by to make the sequence progress. So be careful when we talk about geometric sequences, we're no longer looking at the common difference because there is no common difference. The difference between these two values is different to the difference between these two values. There's no common difference, but there is a common ratio, the number that you multiply by. Okay, So to find the common ratio, it's a little bit different to finding the common difference. Rather than subtracting a value from the following value, you can divide one value by the previous one. So if I divide 16 by 2, I get 8. So my common ratio must be 8. I can check that by dividing 128 by 16, and I should get 8. So if you've been given lots of values, you can actually work out what the common ratio is by dividing. Again, make sure you do it the right way around. And then we need a formula. Remember that formula that we had in orange last lesson for working out any term, any given term. So how can we do this? Well, I've picked one of the terms at random. I've picked this one here, 1024, and I know it's the fourth term, n4. I'm going to divide the fourth term by the first term, and that gives me 512. And 512 is the common ratio, multiplied by itself 3 times. So r, the common ratio to the power of 3. Now you don't need to recall all of this. I'm just showing it to you so that you understand that the nth term for geometric sequences is u1, the first term, here in this case 2, multiplied by the common difference to the power of n minus 1. Look, we've ended up with r3 here, the common difference multiplied by itself 3 times, and we were looking at the fourth term. So it's n minus 1. So this you don't need to worry about too much. This is the equation that we get out for geometric sequences, and it is always the same. So let's have a look a little bit at how we can use this. So we've got an arithmetic sequence, 24, 12, 6, 3. I'd like you first of all to find the common ratio. Then I'd like you to try and find the 8th term of the sequence using this formula here. So pause the video and see if you can work these two things out. Okay, so the common ratio you should have found by dividing one term by the term before. So 12 divided by 24 gives me 0.5. So my common ratio is actually 0.5. We can tell it's less than 1 because the numbers are going down. The 8th term is going to be u8, and it's equal to the first term, 24, multiplied by the common ratio, 0.5, to the power of n minus 1, and n in this case is 8. So here it is, u8 equals 24, first term, multiplied by 0.5, the common ratio, to the power of 8 minus 1. So u8 is 24 times 0.5 to the power of 7. Put all of this into your calculator and you should get that u8 is 0.1875. Always make sure that you write down what it is that you're doing in the exam in the working area, so that if anything does go wrong when you're inputting it into your calculator, the examiner knows that you had the right idea. Okay, another one to try then. So the second term in an arithmetic sequence is minus 15, so now we don't know what u1 is. The fifth is 405. Find the first term and the common difference. Now remember, we are given 2 sets of information. We have 2 missing values, u1, the first term, and r. Think about what you need to do. In this case, it's going to be slightly different, but you can at least write your equations and then check the answer. So pause the video here, write your equations, and then press play again to see what you need to do with them. Okay, so we're given two pieces of information, the second term and the fifth term. So here I've got U2 and U5. Both of them are equal to U1, and we don't know what U1 is. Multiplied by R, we don't know what R is either, but we do know what N is for both of them. So for this one, because it's the second term, it's 2, so it's 2 minus 1. And for this one, it's the fifth term, it's 5 minus 1. And we know what they're equal to. The second term is equal to negative 15, and the fifth term is equal to 405. Now, because we're multiplying here, we can't subtract one equation from another. We've got simultaneous equations again, but we can't subtract them because we've got multiplication instead of addition. What we can do is divide. So here we've got U1 multiplied by r to the power of 4, that's this one here, equals 405. Divided by U1 times r to the power of 1, that's this one here, which equals minus 15. Now when we divide, U1 divided by U1 cancels out. It ends up being 1, so that disappears. When we divide indices, it becomes like this indice is subtracting this one. So it actually becomes r to the power of 4 minus 1, r to the 3. And then we can divide 405 by minus 15, and it gives us negative 27. So r to the power of 3 gives us negative 27, and I don't want the power of 3 there anymore, and the opposite of the power of 3 is the cube root. So I cube root both sides, and the cube root of minus 27 is minus 3. Because minus 3 times minus 3 is 9, times minus 3 is minus 27. So I found the common difference is minus 3. Now I can apply that, and I can either apply it to this formula here, and I'll show you how, or I could divide minus 15 by minus 3. And that would give me my answer for the first term. Because minus 15 is the second term. That only works if you're given the second term. But putting it into this formula here, now we know what r is. So I can say U2 equals U1, we still don't know what U1 is, multiplied by minus 3 to the power of 2 minus 1, because it's term 2, equals minus 15. So let's reorganise this. Minus 15 equals the first term times minus 3, because 2 minus 1 becomes 1, and minus 3 to the power of 1 is minus 3. And then I divide both sides by minus 3. Minus 15 divided by minus 3 gives me 5. So that's a whole lot of information here, and this part is particularly tricky. So write it all down, make sure you've got it in your notes, make sure you understand, and let me know if there's anything that you're not sure of. Because you need to understand what you've done step by step here. And then I'd like you to try page 305 to 306, exercise 7D. Anything again that you haven't finished, you need to complete for homework. Pause the video here, and once you've finished, play it again, and the answers will come up.